Welcome back to the deep dive. For decades, we've all internalized this beautifully simple story about cholesterol.
Right.
LDL is bad, HDL is good, it's clean, it's easy to remember, and it works.
Until it doesn't. And that simple narrative is exactly what our sources are tearing up today. We're moving so far beyond seeing cholesterol as just, gunk in the arteries.
It's way more complex.
It's now seen as this critical determinant of both systemic pathology and exceptional longevity. The whole field is shifting away from just measuring mass to actually counting particles.
Absolutely. So here's our mission for you. We're going to unpack what is maybe the most surprising finding in modern health research, this U-shaped mortality curve with cholesterol.
It's fascinating stuff.
We're going to understand why the rules that apply to you in your 40s are the complete biological opposite of the rules for someone trying to live to be 100.
And to really get that, you have to start with the molecule itself. I mean, cholesterol is indispensable. Its role goes so far beyond just being a risk factor for heart disease.
That's foundational.
It's the absolute foundational component for your cells. It literally holds them together. And it's the precursor for every single steroid hormone your body makes.
Let's really unpack that. I want you to just picture cholesterol as the architect of your cells. It makes up a huge chunk, like 20% to 30% of your cell membranes.
A massive amount.
And its job there is critical. It buffers the membrane's fluidity. Without it, your cells would just swing between being too rigid, almost like a gel, and way too fluid, just unstable.
It's the stabilizer. And that's just structure. Like you said, it's the only precursor for all steroid hormones. Cortisol, sex hormones, all of it starts with cholesterol. Vitamin D, too.
But the molecule itself hates water, which creates a huge problem in the bloodstream.
A massive transport problem.
Why?
Since it's hydrophobic, it can't just float around in your blood.
So the body has to package it up.
Exactly. It needs to be put into these little containers we call lipoproteins. You've got VLDL, which becomes IDL, then LDL. And the risk isn't the particle itself, but what happens when it gets trapped. Once an LDL particle gets into the artery wall and gets stuck, it can get modified oxidized, and that's what triggers the whole inflammatory response. Macrophages come in, eat the particle, and turn into foam cells.
And that's the plaque, the very beginning of it.
That's the hallmark of plaque formation.
Okay, so that brings us to the paradigm shift.
Yeah.
The classic measurement, LDL-C, that's the mass of the cholesterol cargo, is becoming outdated. The new gold standard is something called apolipoprotein B, ApoB.
And what's so beautiful about ApoB is its simplicity. Think of it this way. LDL-C is like weighing the cargo inside all the delivery trucks on a highway.
Okay.
ApoB is just counting the number of trucks. And when you're worried about a traffic jam, it's the number of trucks that matters, not how much each one weighs.
That analogy makes it so clear. So every single one of these risky particles, VLDL, IDL, LDL, has exactly one ApoB molecule on it.
Exactly one. So measuring ApoB gives you the total number of potentially dangerous particles you have. It's a direct count of your exposure.
Which leads to this idea of discordance. Our sources talk about patients, especially with metabolic syndrome, who might have a normal-looking LDL-C.
But their ApoB count is sky high. That's high discordance.
And that group is at a much higher risk for major adverse cardiovascular events. We're talking heart attacks, strokes. So why is that? If the LDL-C looks okay, why is the risk so high?
Because the particles they have are the small, dense LDL, the SDLDL.
The really dangerous ones.
They have extreme atherogenic potential. They're small, so they get into the artery wall easily, and they're really prone to oxidation once they're there. ApoB counts these perfectly. So in midlife, the goal is simple. Minimize the particle number.
Okay, so that's the rule for a 40 or 50-year-old. Minimize the particles. But follow that person into their 80s or 90s and the science just flips on its head. Let's get to the really counterintuitive part, the U-shaped curve.
Right, this U-curve just completely challenges that old mantra of lower is always better. When you plot cholesterol levels against all-cause mortality in these huge studies, the curve dips down in the middle, that's low mortality, but it shoots up on both ends.
So we all know the high end is cardiovascular risk, but the low end? That's its own kind of danger. And it's not heart attacks.
Not at all. We see that people with really low cholesterol, say non-HDL-C below 100 mg/dL, had up to a 42% higher mortality risk than the middle group.
And that risk is from what?
It's non-cardiovascular stuff. Cancer, infections, respiratory disease. It really suggests your body needs a certain baseline amount of this stuff for your immune system and your cells to just function properly.
There's a threshold for sufficiency.
There really is. And the key variable here is age. The link between high cholesterol and death is really strong when you're under 50, but the data shows that risk just fades away after age 70.
Which brings us to the cholesterol paradox. For decades, we've been told to lower LDL aggressively. But when you look at the oldest old people, 85 and up, higher cholesterol actually becomes protective. This is just stunning stuff.
It's completely counterintuitive. I mean, look at the Sardinia Blue Zone study. These are some of the longest-lived people on Earth.
Right.
They found that nonagenarians, people in their 90s, with mild hypercholesterolemia, so an LDL-C of 130 or higher.
Which would be a red flag for a 50-year-old.
A big red flag.
I know.
But for them, it meant a statistically significant survival advantage of over a year. They lived 3.82 years versus 2.79 for the lower cholesterol group.
How do you even explain that? What is cholesterol doing for a 95-year-old that's so important it outweighs decades of potential plaque buildup?
It seems to come down to cellular resilience and immune support. As cells get old, they enter senescence, they get fragile. Higher cholesterol seems to help stabilize these critical structures called lipid rafts in those aging cells.
And those lipid rafts are key for immune signaling.
Vital for it. So it's about keeping the physical integrity of your defense system. For someone over 90, the biggest threat isn't a heart attack 10 years from now, it's pneumonia next week.
So the acute risk outweighs the chronic risk.
Precisely. Having a good supply of cholesterol appears to support that immediate immune fight. It's less of a long-term bomb and more of a short-term fuel for robustness.
That's a critical distinction. Okay, let's flip to the other side of the coin. HDL-C,
Yeah.
the good cholesterol. We were always told, get it as high as you can.
Right. Another simple story.
Yeah.
But our sources show HDL also has a J-shaped risk curve.
So not a straight line.
No. Moderate levels, say 40 to 60 milli-GDL, are definitely protective. But extremely high levels, we're talking above 80 milli-GDL, are now being linked to some really bad outcomes, especially in older adults.
What kind of outcomes? I saw something about fracture risk. How is good cholesterol linked to breaking a bone?
The data is surprisingly strong. Very high HDL-C in older folks has been linked to increased risk of dementia, cognitive decline, and yeah, the most surprising was fragility fractures. About a 14% increase in fracture risk for every standard deviation increase in HDL-C.
That's wild. What's the mechanism there? How does the good guy go bad?
It's all about function. At really high concentrations, HDL particles can become dysfunctional. They start to lose key antioxidant enzymes, especially one called PON1.
Okay.
And when you lose that antioxidant shield, the particle can actually turn pro-inflammatory. It promotes oxidative stress. There's also some evidence it can lead to cholesterol crystallization in tissues, including bone, which would compromise its strength.
Wow. So even with HDL, the goal is balance, not just maximization.
Exactly. It's all that balance.
Let's touch on the genetic blueprints for a second. We know lifestyle's huge, but our genes really set the stage. What are the big players?
The genetic role is just staggering, and PCSK9 is a huge one. If you have certain loss-of-function variants, you're just born with lifelong low LDL-C.
Like winning the genetic lottery.
You really did. These people can have LDL levels 13 to 35 mg/dL lower their whole lives, and their risk of coronary heart disease is slashed by like 47% to 88%. They are naturally protected from birth.
And then there's the gene that connects all of this to the brain, ApoE.
The apolipoprotein E gene, yeah. It's still the most powerful predictor of neurodegenerative risk. The epsilon-2 allele is highly protective against Alzheimer's.
But the epsilon-4 allele,
That's a major risk factor for both high cholesterol and neurodegeneration. It shows you this isn't just about your heart. It's fundamentally tied to your brain health.
so how are the clinical guidelines catching up with all this nuance? The 2025 and 2026 updates have to reflect this complexity.
They are definitely moving away from one-size-fits-all targets.
Yeah.
A big shift is endorsing the SCORE2OP algorithm.
What's that?
It's a risk calculator specifically for the 70 to 89 age group. It helps doctors really figure out if the benefits of a statin are worth the potential side effects in an older person, acknowledging that U-curve.
That makes so much sense. Avoiding overtreatment. But on the flip side, for the highest risk patients, the targets are getting even more aggressive.
That's right. For people at extreme risk, someone who's already had a heart attack, for example, the new LDL-C target is incredibly low, less than 40 milli-GDL. The thinking there is you have to do everything you can to lower that total lifetime burden of ApoB particles.
And there's a new required test, too, that speaks to the genetics.
Yes. The guidelines now say lipoprotein, or LPA, should be measured at least once in every adult's lifetime. If it's over 50 milli-GDL, that's a major independent risk factor that's almost entirely genetic. You need to know that number.
Shifting to lifestyle for a minute, Our sources really hammer home that for most people, maybe 90% of us, lifestyle is what really drives longevity.
And this is where we found a truly shocking piece of data.
The sleep data.
The sleep data. Getting less than 7 hours of sleep consistently is a more powerful driver of a lower life expectancy than a bad diet or not exercising. It's second only to smoking.
That is the most actionable and, frankly, depressing piece of information in this whole dive. It just instantly reframes what's important for your health.
It really does. But, physical activity is still essential. Just 3.5 hours a week can extend your life by about 8 years. And it doesn't just help your heart. It promotes neurogenesis, making new neurons in your brain.
Which directly fights cognitive decline.
Directly.
And finally, a quick reality check on supplements. This sport trial really put that debate to bed, didn't it?
It did. It was a head-to-head comparison, and it confirmed that a low-dose statin is just vastly superior for lowering LDL-C compared to popular supplements.
Things like red yeast rice, fish oil.
Red yeast rice, fish oil, cinnamon. They showed basically no significant benefit over a placebo for lowering LDL-C. Clinical management needs tools that are actually proven to work.
Okay, so let's synthesize all this. What's the final takeaway for someone listening?
It's that the dynamic has to be managed by age. In your middle years, say 20 to 70, the name of the game is minimizing your total lifetime burden of ApoB particles. That's how you get to old age with clean arteries.
But once you cross that threshold, once you're in your late 80s or 90s, the game changes completely.
The focus shifts entirely to immune resilience and just keeping your cells from falling apart. That cholesterol paradox suggests that for this group, a moderate cholesterol level might actually be a sign of robustness, not a threat.
So what does this all mean for you? The future of managing your lipids is precision. It's about incorporating your ApoB count, your LPA level, your genetics. It is no longer one size fits all.
We're really entering an era of personalized geroscience. Context and age define what's optimal.
And here's a final provocative thought for you to chew on. Groundbreaking research has already shown it's feasible to use gene therapy, AAV-based therapy, to replace the risky ApoE4 allele with the protective ApoE2 allele in models.
Essentially swapping out a bad gene for a good one.
So if timing is everything in managing this whole continuum, both the heart disease risk early on and the resilience needed for old age, how might a future defined by sustained gene modulation change how we think about longevity, decades before any real risk even starts to show up? We'll leave that with you.